Hello, and welcome back to the channel. Today, we're unraveling a critical component in modern distributed architectures, mastering API gateways, the brain of scalable microservices. At its essence, an API gateway acts as a single entry point for all client requests into a microservices ecosystem. Instead of clients directly interacting with numerous backend services, all requests are first directed to the gateway. This central proxy then intelligently routes, filters, transforms, and secures that incoming traffic. Its primary benefits include reducing the direct exposure of your internal microservices to external clients, thereby enhancing security and simplifying client-side consumption. Furthermore, the API gateway is the ideal place to enforce global policies such as rate limiting, authentication, and authorization. You can envision it as the sophisticated air traffic controller for your microservices, managing and directing every inbound and outbound flow. The API gateway takes on a multitude of crucial responsibilities, centralizing concerns that would otherwise need to be implemented within each individual microservice. These include request routing and load balancing, directing incoming requests to the correct backend microservice, often incorporating internal load balancing to distribute the load across multiple instances of a service. Authentication and authorization, verifying client identity and permissions. This is where you typically handle mechanisms like validating JWT, JSON Web Tokens, or managing OAuth 2 flows. Request transformation, modifying client requests before forwarding them to a service. This could involve translating data formats, example, XML to JSON, adding/removing headers, or restructuring payloads. Response aggregation. For complex operations, the gateway can query multiple backend services, combine their responses, and present a single, unified response back to the client. This simplifies client-side development by abstracting internal service orchestration. Rate limiting, protecting your backend services from abuse by limiting the number of requests a client can make within a specified time frame. Caching, logging, and monitoring. Implementing caching of API responses to improve performance, centralizing logging for all requests, and providing a single point for collecting metrics for system monitoring and observability. The market offers several powerful tools for implementing API gateways, each with its strengths. Kong, a very popular open-source API gateway known for its high performance and extensive extensibility via Lua plugins. It can be deployed on-premise or in the cloud. AWS API Gateway, a fully managed, highly scalable service provided by Amazon Web Services. It handles the underlying infrastructure, allowing developers to focus purely on defining API endpoints, integrations, and policies. Zoll. Developed by Netflix, Zoll is an open-source API gateway widely used in JVM-based microservices ecosystems. It's known for its powerful routing and filtering capabilities. Apigee, Google Cloud Apigee, a comprehensive, enterprise-grade API management platform that includes robust API gateway functionalities, offering advanced analytics, developer portals, and security features. Jinx and Express Gateway. While Jinx is primarily a reverse proxy, it can be configured to act as a basic API gateway. Express Gateway is a modern, open-source API gateway built on Node.js and Express.js, offering a more developer-friendly experience for certain stacks. The choice of tool often depends on your cloud stack, anticipated traffic volume, the need for custom plugin development, and your overall ecosystem. It's crucial to distinguish an API gateway from similar, yet fundamentally different, components like a load balancer and a reverse proxy. While they might share some overlapping functionalities, their primary roles, level of intelligence, and traffic handling focus differ significantly. Let's break down the key differences between these three components. API Gateway. Think of an API gateway as the smartest traffic cop for your services, especially in a microservices setup. It understands the application layer, layer 7, meaning it grasps the full details of your HTTP requests. It's incredibly intelligent, handling complex tasks like authentication, data transformation, response aggregation, and rate limiting. Its primary job is to manage and secure your microservices, making them easier for clients to consume. Examples include Kong, Zoll, and AWS API Gateway. Load Balancer. A load balancer is more like a traffic director that spreads work evenly. Its main goal is to prevent any single server from getting overloaded. It operates at either the network layer, layer 4, or sometimes the application layer, layer 7, for simpler routing. It's generally less intelligent than an API gateway, primarily distributing incoming connections or requests among identical servers to ensure load distribution and high availability. Common load balancers are AWS YLB and HAProxy. Reverse proxy. A reverse proxy acts as a gateway in front of your web servers. Clients talk to the reverse proxy, and it then talks to your actual servers. It typically operates at the application layer, layer 7. It has medium intelligence, capable of basic routing, SSL termination, decrypting secure traffic, serving cached content, or compressing responses. It's used for routing requests to different backend web servers, enhancing security and improving performance. Jinx, Envoy, and Varnish are well-known reverse proxies. In essence, an API gateway is a specialized and much more feature-rich type of reverse proxy specifically designed to handle the complexities of microservices. While a load balancer focuses on distributing network load, an API gateway centralizes application-level concerns and provides a unified entry point to your services. API gateways are fundamental to the operation of some of the world's largest digital platforms. Netflix famously uses Zoll as its edge service, processing millions of requests per second. It handles all incoming traffic, routing it to hundreds of back-end microservices, performing authentication, and managing various cross-cutting concerns. Amazon leverages a highly centralized API gateway architecture across its vast array of services. This allows them to expose unified APIs to customers while abstracting the complexity of their underlying multi-service applications. E-commerce platforms typically use an API gateway to intelligently route incoming requests to specialized microservices for functionalities like the shopping cart, authentication, user profiles, or the checkout process. This modularity makes development, deployment, and scaling much more efficient. Furthermore, API gateways are ideal points to implement caching for API responses, which significantly reduces repeated downstream calls to backend services and improves response times for clients. They also play a crucial role in enabling API versioning. By handling routing based on API versions, gateways allow you to evolve your backend services without immediately breaking compatibility with older client applications. To summarize our discussion on API gateways, an API gateway is an essential component for effectively managing, securing, and scaling complex microservices architectures. It centralizes critical functionalities like security, authentication, authorization, intelligent routing, rate limiting, data transformation, and response aggregation. It's important to understand how an API gateway differs from generic load balancers and reverse proxies, specializing in application-level concerns for microservices. You are now familiar with prominent tools in the market, such as Calm, Zoll, and AWS API Gateway, each suited for different use cases and ecosystems. Mastering the concept of API gateways is not just a key topic for system design interviews. It's a fundamental aspect of adopting a modern backend architecture mindset, empowering you to build highly scalable and maintainable distributed systems. Before you go, I'd love to hear from you in the comments. If you found this video helpful, do give it a like, share it with your friends, and of course don't forget to subscribe to the channel to help us grow. I will see you in the next one. Till then, happy learning.